بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. الله أكبر الله أكبر الله أكبر، لا إله إلا الله، الله أكبر الله أكبر ولله الحمد. Hi everyone, today we are going to solve a very special problem from Pan-African Mathematics Olympiad 2019. Let an starting from 0 to infinity be a sequence of real numbers defined as follows: a0 equals 3, a1 equals 2, and a2 equals 12. Of course, these called the initial conditions, and we have a recurrence relation to an plus 3 minus an plus 2 minus 8 an plus 1 plus 4 an equals 0 for n is greater than or equal 0. Show that an is always a strictly positive integer. Of course, a0 and a1 and a2 is already a positive integer, so we need to continue the proof that a3 and a4 and a5 and so on is also a positive integer. I am Mr. Sherif Hamid with you, math and mechanics teacher at STEM Kafr Sheikh High School in Egypt. Let's start with our formula. 2an plus 3 minus an plus 2 equal 4 times 2an plus 1 minus an. And we will start substituting with n equals 0, n equals 1, and so on, till we observe the pattern and obtain a generalized formula. So when we substitute with n equals 0, we will obtain this one, and we can divide by 2. And similarly, we can divide with n equals 1, so we will have this one, and we also can divide it by 2, and we will have a4 minus a2 divided by 2 power 2 equals 4 times a2 minus 3 over 2 power 2. Of course, as you can see that we can make a generalized formula. Of course, a2 is repeating each time, and also 3 is repeating each time. Of course, a0, which is 3, a1 equals 2, and a2 equals 12. These are the initial conditions, and in terms of them we can also obtain the other terms. So you can see that this is 4, and this is square, which is power 2, and this is 2, and 2, this is 1 is fixed, this is not changing, and we have here 2 power 2. And if we make another one, for example 5, we will have here 2 power 3, and we will have here 2 power 3, and so on. So the power is increasing by 1. So the difference between this a and the power is always 2. You can see that this is 3 and this is 2 power 1. Here is 4 and 2 power 2. When it is 5, it will be 2 power 3. So the difference between them is always 2. So we will continue this pattern till we reach a power n, an or 2 power n. So an plus 2 minus 12, which is a2, because it is not changing when we substitute with n equals 5, equals 6, and so on. So an plus 2 minus 12 divided by 2 power n equals 4 times an minus 3 divided by 2 power n. We will simplify this one, and 12 divided by 2 power n will be cancelled with negative 12 divided by 2 power n, and we found this generalized formula: an plus 2 equals 4an. And from here the proof is obvious, and we will make more steps to make it easier for you. We can start substituting with n equals 0, n equals 1, n equals 2, and of course the difference is 2, so we will have to divide the solution into two forms. One of them both even numbers, and the other one is odd numbers. So when we start with n equals 0, so a2 equals 4a0, and all the even numbers will be in terms of a0. And similarly, when we substitute with n equals 1, so a3 equals 4a1, and all odd numbers will be in terms of a1. So when we continue the odd numbers, a5 will equals 4a3. Of course, all the relation will come from the last one here. So a5 equals 4a3, and substitute with a3 with 4a1, so it will equal 4 square a1. As you can see, a1 is already known that it is a positive integer, and as a result a5 will also be a positive integer, because it is a closed system, because all of them will be a positive integer. So we can make a generalized for the odd numbers. a2n plus 1, of course, is an odd term. The generalized odd term a2n plus 1 equals 4 power n a1. Of course, as you can see, a7, a9, a11, a13, and so on will always be positive integer. And for the even number, similarly, a4 will equal 4 square a0, a2n in general, a2n will equal 4 power n times a2. a2 of course is positive integer, and a1 is also positive integer, where n is even. So whatever the kind of n, it is even or odd, it will always be a positive integer. And not only that, we can also conclude that starting from a3, that all an will always be divisible by 4, as you can see, because all of them is multiplied by 4 power n. So all of them will be divisible by 4, as you can see, and our proof is finished. And I hope that you understood this very well, and it was a simple question. And see you later for another problems. Thank you so much.